All right, looking at two variable linear inequalities. If you have two variables, that means you're having an x and a y. You're looking at two dimensions. So you're going to be graphing these on a coordinate plane instead of a number line. And it's important to look at their sign. The sign tells you how to create the graph. Is it going to be solid or dotted? And do you shade above or below? So if you see that y is less than whatever the value is, that means that it must be less than. It's going to be a dashed or dotted line, and you're going to shade below. This means that the points or ordered pairs that are actually on the graph line do not count as a solution. If it's greater than, then you're still doing a dotted or dashed line because it doesn't say equal to, which means the points on the line are not included. However, you shade above because it's greater than. If you see less than or and equal to, so it has the little line under it, y is less than, so you're shading below. And since it can be equal to, which means the ordered pairs on the graph line do work, it's a solid line. This one here, y is greater than. That means you're shading above, and since it's equal to, it's a solid line. So looking at it a little more in depth and remembering the rules when solving inequalities, recall when adding and subtracting, there's no difference. You treat them just like you would equations. However, if you're doing multiplication and division and you have to break that negative from the variable and move across the inequality sign, you must flip or reverse the symbol. As a reminder as to what I just mentioned above, if you have a dotted line, so you have less than or greater than, then the order pairs on the line do not count as a solution. They can only count if there's the equal to symbol, and when graphing, you will see a solid line. If you graph it, you will see a shaded area. Anything that exists within the shaded area, so there's tons of answers, those are solutions. However, points out here that are not in the shaded area are not solutions. They would not work if you were to plug them into the equation. So looking at a first example, 3x plus y is less than or equal to -1. Your objective is to get it into that format as seen up here, the y equals mx plus b, but using inequalities. So in order to get this y by itself, you must do inverse operation. And since this is positive 3, you subtract 3x from both sides. Then you get y is less than or equal to -3x minus 1. Keep in mind, when you're subtracting, there's no flipping of the sign. It still remains the same. Once I have it in the proper format, now I can justify and analyze. Since it says y is less than and equal to, I know it's going to be a solid line. And since y is less than, I'm shading below. So the way I like to think of it is once you draw your line, put your hand out. The palm or the bottom of your hand is always the below. The top of your hand is always going to be the above. So since shade below, you shade down in this area. Keep in mind, since it's a solid line, the dots on the graph line are solutions. If I were to give you the ordered pair -3, 3, and I asked you, is this a solution to this problem? If you were to plug this guy in to the equation, it should be proven true if it is a solution. Otherwise, you can also look at the graph and see, is it in the shaded area? So -3 is back here, up 3, yes, that would be a possible solution. Are there a lot more? Yes. If you were given 0, -1, 0, -1, it exists on the line. But since it's a solid line, then yes, It is a solution. If I gave you 1, 1, this is not in the shaded area. So that would be no, that is not a solution to the problem. You see 2x minus 3y is greater than 6. You must get the y by itself. So to do that, you have to subtract 2x, subtract 2x. So then you have negative 3y is greater than negative 2x plus 6. Keep in mind, the y is still not by itself. So right now, it's negative 3y. I must break the negative 3 from the y. Remember, if you have to break from the y and you see that negative number, that is when you want to reverse your symbol. So since it's greater than, I'm reversing it to less than. Now you divide everything else by 3 and simplify. So your final equation, inequality, is y is less than 2/3 x minus 2. It is going to be a dashed line. What does that mean? That means that the values that would be on the line are not going to be solutions to the problem. Okay, so we graph the line. It also says y is less than. So I put my hand on top of the line and I shade on below, which is at the palm, so I shade below the dotted line. If I were to extend and give some questions to say, are these solutions? If I gave you negative 3, negative 5 on the graph, if I were to go back 3, down 5, it is in the shaded area. So yes, that would be a possible solution. If I gave you 0, negative 2, that exists on the line. Oh, but the line is dashed. So that means no, it cannot be on the line because it doesn't say equal to. So if it's a dashed line, it cannot be on the line. 0 and then down or up to for this one up here. That's not in the shaded area, so this one is also no. X minus y is less than 5. You must get y by itself, so in order to do that, you need to remove the x, so you do minus x minus x. That means you're left with negative y is less than negative x plus 5. You see it's a negative y. If you have to break a negative from the y, that means you need to flip the sign. So now it says y is greater than x minus 5. Since y is greater, you're shading above, and since there's no line under here, it's a dashed line. What does that mean? That means the values that are on this line are not going to be solutions, that they must exist above the line in that shaded area. Sometimes you'll actually have to do distributive property. So for this one here, if you ever see parentheses, your first objective is to get parentheses away, so you must distribute. For this example here, 2 gets distributed to the x and 2 gets distributed to the y. So then it reads 4x is less than or equal to 2x plus 2y. Now we want to get the y by itself, so I'm going to move the 2x from this side and move him over here. How do I do that? Since this is plus 2x, you're going to subtract 2x. What you do to one side, do to the other. All right, 4x minus 2x gets you 2x is less than or equal to 2y. We must now get the y by itself, so divide by 2, divide by 2. It says x is less than or equal to y. Well, that's not properly written, so I'm just going to reverse it and put it proper. Make sure your sign is open to the y. So when you rewrite it, it's still open to the y. Now what does that mean? Y is greater. That means I'm going to shade above, and since it has the equal to, it's also going to be a solid line. So if I gave you ordered pairs, there are 2 ways to see if they are actually solutions. And one of them is by substituting your x and the y from the ordered pair, or in other words, plugging it in. So if you were given, is 5, negative 2, an ordered pair, a solution to the inequality, what you would do is you would plug in the x in the x position and plug in the y in the y position. Don't forget to use parentheses because it means multiplication when you have them existent next to coefficients. Then once you solve it, if you see 16 is less than 5, is that true? No, it's not true. If the statement is proven true, then it's a solution. If it's proven not true, like this case, then no, 5 comma negative 2 is not a solution. You would also notice that when you graph that line, this ordered pair would not be in the shaded area. You can also graph the inequality and then do what we did in the previous section. Take that ordered pair and see, is it in the shaded area? So where I see the x, I'm going to take in my ordered pair the x value. Don't forget, when you plug in, you want to make sure you use parentheses so that you do the proper operation that's being asked. So for this one here, the 3 goes where the y is less than or equal to negative, wherever the x is, I'm going to plug in what I have here plus 3. Now I just need to solve. All right, well, negative times 0 is 0 plus 3. 3 is less than or equal to 3. It's not less than, but is it equal to? Yes. So that means that this statement is true. If you're given an inequality and you are asked to graph the solutions, you must solve it first to find out which ordered pairs, or what is the statement. Do I have a solid line or do I shade it above or below? So as far as the line, right now, I can already tell that this here is going to be a dotted line. Since it doesn't have equal to, I'm going to go ahead and write dashed or dotted. That way I remember when I graph, I need to have it to have a space in between. What does that mean? That means the solutions cannot be on this line. All right, but now I need to know if I need to shade above or below. So I need to finish solving this. Since it has negative y out in the front, what that technically means is negative 1. You cannot leave a number or a negative sign in front of the y. So you must get rid of that. Since it's y times negative 1, you do divided by negative 1, divided by negative 1, divided by negative 1. What you do to one side, you do to everything on the other side. Well, notice I'm breaking a negative from the y. That means that the sign has to be reversed. So right now I'm reversing my sign. Now my y is there. Negative divided by a negative makes a positive, so now it's just positive x. And then 4 divided by a negative makes negative 4. Now I'm done. So now I know that I'm going to be shading above. And the reason I know that is because it says y is greater. So this is going to be shading above, and it's going to be a dashed line. All right, so 0, negative 4, 0, negative 4, I'm going to put my dot. 1, negative 3, I'm going to put my dot. Now, when I go to graph it, I need to recall that it is a dashed line. So I'm just going to draw, pick up my pencil, draw, pick up, and just go all the way through the graph, and then put my arrows on the side. So now I have my dashed line, but I'm not done. It says I need to shade above. Okay, so my right hand doesn't fit on that line. So I'm going to use my left hand. And remember, above is shading on top of your hand. So that means that this area here are the solutions for this inequality. Anything in this area is going to be a solution. What is not a solution? Well, the ordered pairs that we are given, 0, negative 4, not a solution. 1, negative 3, not a solution. So even though they're used to graph the line, they're not solutions. Why? Because it's a dashed line. And so the solutions cannot exist on this line. Because if you were to plug these in, they would be proven false. What else is not a solution? Anything in this area. So 3, negative 3 would not be a solution. So if you're going to a cookout that has hamburgers and hot dogs being served, so there's 2 different things being served. Hamburger meat costs $3 per pound and hot dogs cost $2 per pound. but you cannot spend more than $30. So $30 is how much you can spend. So $30 must be greater than or equal to, because that's the max you can spend, your hamburgers plus your hot dogs. So my hamburgers, I'm going to make X, and my hot dogs, I'm going to make Y. So for hamburgers, the rate or the slope is $3 per hamburger plus $2 per hot dog. So now I have my inequality. So in order to do that, I'm going to move my 3x, and what you do to one side, do to the other, so that gets eliminated. And then you have negative 3x, and then since 30 is positive, it's plus 30, and then the 2y is here. I'm not done yet. I must get the 2 away from the y, so divide by 2. What you do to one side, you have to do to everything on the other side. Now that you have that, you simplify it. 30 divided by 2 is 15. And then this guy here, you just leave it as an improper fraction. Now this isn't written proper, so I'm going to go ahead and reverse it. Since it's pointing to the y, when I reverse it, I need to make sure it's still pointing to the y because I'm just rewriting it proper. I'm going to go ahead and put my slope, and then I'm going to have my y-intercept. Now that I have my inequality, I can now determine if it's going to be shaded above and below. Since it says y is less than, then I know that I'm going to be shading below. Can those solutions be on this graph line? Yes. So if you were to then graph this, you would title it as cookout, and since it's food, you can't have negative food. And when you label your axes, I just use the slope, so I know it's going to go, hot dogs are going to go up, and then the y, so I just look at that, write the ticks out. And I know from this equation here that I'm starting with my y-intercept of 0, 15, and then I know that the next point is 2, 12, and then I connect the line. Since it's equal to, it's a solid line. What does that mean? What are possible solutions? Well, again, you can't have negative, but you look anywhere in this shaded area. So it can be on the line or in the shaded area. That means that if I were to think, okay, 5, 6, that is right on the line. So yes, you can have 5, 6. What does that mean? Well, since X is your hamburgers, that means you can have 5 pounds of hamburger while having 6 pounds of hot dogs and still keep your budget at the max of $30. So realistically, there are multiple solutions. You just need to make sure that it's anything in the shaded area or existent on that line, since it is a solid line.